Okay, college algebra, let's do 1.4, quadratic equations. There's a lot going on here on the first few pages. It looks scary, but it's really not. Really, there are a few methods for solving quadratic equations. First, but in all situations virtually, you need to set them equal to 0 first, because one thing we know, if two numbers multiply to 0, one of them has to be 0, and when it says solve using the zero factor property, it's really telling you to factor in order to solve. So when you factor, that's where you're looking for two binomials that multiply to a trinomial usually. You can also complete the square, which is the scary thing down there, but we'll actually do it in some problems and it's not so scary. It just looks scary in theoretical terms at the bottom of the page. If you can get x squared is equal to a number, then you can use the square root property, but if there's any x's in there, you can't use that, with the exception of completing the square. And then, of course, there's the one everyone seems to like, the quadratic formula, which we'll get to in a bit. So let's look at some problems using completing the square and talk about these steps. These steps are useful. This looks scary, but these steps are useful. So in order to complete the square, it says divide by a. A is the number in front of x squared, and ax squared plus bx plus c. So in this case, it's a 1. There's nothing to divide by. This is move c to the other side. When you do that, my suggestion is always to leave a blank. So we subtracted 2 on both sides, because anything I add to one side, I'm going to have to add to the other. Take the number in front of x, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. That will be added to both sides in the blanks. Now, the whole point of this is to make this a perfect square, the same binomial times itself. And that binomial will always be x, and then whatever the sign is here, and this number that you cut in half to, squared. Why? Because x plus 3 times x plus 3, if you use the distributive property, will give you x squared, and then it'll be 2 3x's in the middle that you combine to get to 6x, and then 3 times 3 is 9. On the other side, we just add those two numbers together. Negative 2 plus 9 is 7. Now when you have something squared and you're trying to get x by itself, you need to take the square root of both sides. So we get x plus 3 equals plus or minus square root of 7. The reason we use plus or minus is we introduced the idea of the square into the equation. So we need to deal with the repercussions, the fact that negatives and positives square to the same thing. Now to get x by itself, we move the 3 to the other side. So x equals negative 3 plus or minus the square root of 7. Now normally when you factor, you get two answers. It's important to note this is also two answers. This is negative 3 plus the square root of 7. That's one answer. And negative 3 minus the square root of 7 is the other answer. They are conjugates of each other, which they tend to come in pairs like that when completing the square. Sometimes the conjugate pairs can look different. For example, if that were the square root of 16, then we can convert it to 4, and then all of a sudden it's not clear it's a conjugate. But in this form, before you simplify, it should always be a conjugate. Now, let's do this again. 3x squared plus 12x plus 7. This time we have an a to divide by. Divide everything by 3. So we get x squared plus 4x plus 7 thirds equals 0. Again, move c to the other side, which is the constant. X squared plus 4x plus blank equals negative 7 thirds plus blank. Cut the number in half, so 4 divided by 2 is 2, and square it. 2 squared is 4. That 4 goes up here. The 2 slides down. X plus 2 squared. Now I need to do negative 7 thirds plus 4, get a single term. 4 is equal to 12 over 3. So when I add negative 7 plus 12, I get 5/3. Again, how do we get rid of a squared? We take the square root. So we get x plus 2 equals plus or minus square root of 5/3. And then we will move the 2 to the other side. X equals negative 2 plus or minus the square root of 5/3. Now, many people think completing the square is a lot of steps, yet somehow they think plugging everything into a formula, the quadratic formula, is somehow better. Now here's the thing. The quadratic formula, which is the negative b plus or minus the square root of b squared minus 4ac all over 2a, which is down here at the bottom of the page, is just all of completing the square, all of those steps we just did, combined into one single step. So it just means that there are more different places in the quadratic formula you can make the error at one time. Now, there are some things that come from this that people often forget, which are arithmetic mistakes, but completing the square and the quadratic formula are actually the same thing. So let's look at how we use the quadratic formula. Solve the following using the quadratic formula. 2x squared plus 4x plus 5 equals 0. So here we have a equals 2. It's the number in front of x squared. B equals 4. C equals 5. And of course I'm going to write this on top of the page. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You will need to know the quadratic formula on the test. It's worth points just to write it right, and then you have to use it. I promise you now, you need to know it. So let's plug in our pieces. Negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 5 all over 2 times 2. That's negative 4 plus or minus the square root of 16 minus 40 all over 4. 16 minus 40 is negative 24. In the past, you probably had to stop here, but we now know what to do with negative square roots because of section 1.3. We pull the I out. So I'm just going to make a little note up here. That would be I times the square root of 24, just I times the square root of 4 times the square root of 6. The square root of 4 is 2, so this whole thing is negative 4 plus or minus 2i square roots of 6 all over 4. Of course, we can split it into two parts, negative 4 over 4 plus or minus 2i square roots of 6 over 4. Negative 4 over 4 is negative 1. 2 over 4 reduces to 1/2, so plus or minus I square roots of 6 over 2. This is the same answer you would have gotten if you did completing the square. Let's do it one more time on the second problem. In that case, A is 3, B is negative 1, C is 5. So again, same formula. Negative negative 1 is a positive 1, plus or minus the square root of negative 1 squared minus 4 times 3 times 5 all over 2 times 3. So that's 1 plus or minus the square root of, this is 1 minus 60 all over 6, or 1 plus or minus the square root of negative 59 over 6. So you can pull the I out, however 59 is not going to break down. This is 1 plus or minus I square roots of 59 over 6. And that's as simple as we can get it. And we will continue this in the next video.